All right, this lesson is on arithmetic sequences and series. A sequence is a function whose domain is the set of natural numbers, the counting numbers. The terms of a sequence are the range elements of the function, and the difference between the terms is a constant called the common difference. An arithmetic sequence is a sequence in which each term after the first term is a sub 1, is equal to the sum of the preceding term and the common difference d. So the first term is a sub 1, second term is a sub 1 plus d, the common difference. Next term a sub 1 plus 2d, and so forth. All right, so for this first example, the common difference is going to be just take any two terms that are next to each other and subtract them. So 16 minus 4, 16 minus negative 4 is positive 20. The nth term of a sequence is equal to a sub n minus 1 plus d, where a sub n minus 1 is the n minus first term in the sequence. So a sub n, the nth term in the sequence, is equal to a sub n minus 1 plus d, the common difference. This is referred to as the recursive formula. The nth term in the sequence, if you know what the first term is, you can express as a sub 1 plus n minus 1 times d. So the first term plus whatever term that you are looking for minus 1 times the common difference. So given that a sub n equals negative 17 plus 7n, you should be able to determine the first 5 terms in the sequence and the 52nd term in the sequence. To do that, you just replace the n with the term in the sequence, the number term in the sequence. So if you're trying to find the first term in the sequence, replace the n with 1, calculate, and you get negative 10. Again, the second term in the sequence, replace the n with 2, and so forth. So the first term in the sequence is negative 10, second term is negative 3, third term 4, fourth term is 11, fifth term 18. In the 52nd term, just replace the n with 52, and you get 347. All right, so given 2 terms in a sequence, you should be able to find the recursive formula. The way that you do that is you use that same formula, and then we're going to just create a system of equations. So we're going to find out, we're going to create an expression for the 11th term and for the 37th term. So for the 11th term, the 11th term is negative 115. It equals a sub 1, the first term, plus 11 minus 1 times d. 11 is the number term that it is in the sequence. So 11 minus 1 is 10. So now we have negative 115 equals a sub 1 plus 10d. We're going to do the same thing for the 37th term. 37th term is negative 375. So we would write that equals a sub 1 plus 37 minus 1, the 37th term, minus 1 times d, the common difference. And now we have a system of equations, 2 unknown variables, 2 sentences, and we just need to change the sign of everything in the second equation and then add them up. When we do that, the a sub 1s will cancel. That'll give us 260 equals negative 26d. Calculate d, and we get negative 10 for the common difference. So since the common difference is negative 10, we can write the recursive formula. A sub n equals a sub n minus 1 minus 10. To find out what the first term is, we could just plug in negative 10 into either one of those equations, those simplified equations on the right side. I just used the first equation, negative 115 equals a sub 1 plus 10 times d, which is negative 10. 10 times negative 10 is negative 100. Add 100 to both sides, and we get a sub 1 equals negative 15. All right, an arithmetic series is the sum of all the terms in a sequence. So we have the following sequence. To find out what the series is, we just add up all the terms in that sequence. The sum of a finite arithmetic sequence, the sum of a finite arithmetic series, we use the following formula. So you're going to add the first term in the sequence plus the last term in the sequence, and then you're going to multiply that quantity by half the number of terms in the sequence. For example, for this sequence, to find the series, the sum of the sequence, we just add up all four terms. So this series is 120. All right, for this example, we're using sigma notation. So below the sigma is the symbol that looks like an E. And below the sigma, that tells us what the first, what we're starting with. It's just a way of counting. So we're starting with 1. The first value of I is going to be 1, and the last value of I is going to be above the sigma, which is 25. All right, so we're gonna essentially count from 1 all the way up to 25. So there's 25 terms in the sequence. So n is 25. So a sub 1, the first term, we just replace the I with 1. 4 times 1 is 4. 4 minus 2 is 2. So the first term in the sequence is 2. And the 25th term, the last term in the sequence, is just 4 times 25 minus 2, or 98. So we're going to add those two numbers together, 98 and 2, to get 100. And we're going to multiply that by half the number of terms in the sequence. So 2 divides into 150 times. 50 times 25 is 1250. And lastly, again, sigma notation. Now we're told that the series is 333. The sum of all the terms in the sequence is 333 when we want to determine how many terms there are in the sequence. So we're going to use the same formula. We're just going to work backwards. So S sub n is 333. And again, we don't know what n is. So we leave the n over 2. And the first term, we just replace the m with 1. 8 times 1 is 8. 8 minus 3 is 5. And then n sub n is just 8n minus 3. All right, we just replace the m with n, the nth term. 5 minus 3 is 2. First thing I did was multiply both sides by 2 to get rid of that 2 in the denominator. That's how I got 666 equals n times the quantity, 8n plus 2. And then distribute the n. You see that we've got a quadratic equation. Set the whole thing equal to 0. And you can plug it into a quadratic formula calculator to get the two values. We get negative 37 over 4. And we get 9. Now, since n represents the number of terms in the sequence, it should be a whole number. So our answer is actually 9 for n.